Hi and welcome. This time around we have an interesting customer project. I'm not a car expert, so I'm just going to be repeating the explanation of what these parts are. They've got a really interesting history. So the engine that these came from was originally designed by a company that made the Pierce Arrow in the 1930s. It was a V12 and incredibly torquey, two spark plugs per cylinder, very robust, had two distributors. And they went bankrupt in 1938, and they got bought by a company called Seagrave that made fire engines, and the motors were so powerful they started using them in fire engines. Seagrave bought all the tooling to make the engines and made some minor modifications to them, and maybe the dual spark plugs came after. I'm not entirely certain. Maybe Seagrave added that, or maybe they were there before. But the end result was you had two distributors in the motor, and the customer, I've got these shafts here made up with the bottom of the distributor. This is the gear that goes down in the motor. It looks like an eccentric cam, and this piece mates up with I think it was this part of the shaft here that had a key in it as well as a pin through it, so they were really serious about not having a failure. And then the top of the distributor mated with that keyed part right there, and it sat in this piece right here, and this lets you adjust timing on it. Hopefully I got all that right. And the customer is going to modify it from a dual distributor to a single distributor. So he already cut a little bit off the end. It used to match this piece over here. This part went down into the engine and drives the distributor. And what he wants me to do is he wants me to turn a little boss here that is concentric with the inner shaft, which is missing the bushing on that side, but bushing is still there on this side, and concentric with this. But he wants me to turn this down just so that it's round, and then we're going to part off the end of this guy. And once we've got that, then he wants me to take this cold rolled here, and he wants to make a piece that'll fit over that flange with an interference fit that he's going to weld on. And I think this is cast iron. It looks like cast iron. He says he can weld that without any problem. So he's going to weld that piece on there, and then the top of it is going to mate with, I believe, this flange here, and he's going to mount the distributor on that, and then we're going to make a new shaft, I believe. This shaft is reduced in the middle, so it's supposedly nominally 5/8 on each side with 10,000ths reduction in the middle to allow oil to get in there, and apparently we're going to remake that shaft too. So first we're going to start by popping this guy in the lathe, and we're just going to turn down this section here until it's round, whatever diameter that is, and then we're going to part this guy off. So I'm going to grab it by this end. Since we're not keeping this end, I don't want to risk damaging these guys right here, so we're going to head over to the lathe next and chuck that guy up. So I've got this guy loaded in my 6-jaw chuck, and this boss right here is parallel to that shaft, and this is a set true chuck, so it was off by a couple thousandths, as you can maybe see there. And so I'm going to dial this guy in until it's right on the money, or at least as close as I can get it for start. Okay, it's within 1/2 thousandth. I think that's more than good enough. The way the set true chuck works, it's got these adjusting screws here, but before you can do those, you've got to loosen all 6 screws going around the top of the chuck. So I left them loose but snug. So I'm going to sort of tighten them in a car bolt pattern, except there's not an odd number. So with a set true chuck, every time you change diameter, you need to reset it if you want it to be perfectly accurate. They're not just set once and forget, but if you keep the same diameter, they're supposed to be reasonable. So we've got about a 1/2 thousandth of eccentricity, which I think I'm going to call good. And as long as I'm at it, let's see how we are down here on this race. I'm going to put a live center in the end of this. It's about the same half thousandths. Boy, this thing really went in straight. And I probably don't even really need the center in place, which there's a bushing in there, so maybe I won't. There's a bushing in the end. It looks like the bushing's kind of beaten up. So I probably don't need a live center at the back here, down at this end over here, because I'm working up right next to the chuck. Since I've got the part reversed, everything just worked out. So I'm going to just take off enough material till this is round right here, and then we're going to part off the end. This is the tool I'm going to be using. This is a Kennametal tool, and I can plunge right in. It's a parting tool, but this particular tool allows you to go side to side as well. So it's not just a single purpose tool. So it's really handy. Alrighty, so we're just going to go in and touch off and make this round, and we're going to go between here and here. I don't think I've plunged quite far enough yet, but I'm going to go side to side and just clean up the spot I need to here. Okay, so it looks like we cleaned up most of it, but down here, not quite all of it. Wow, that is amazing. We've gone in a little. This is a pretty rough casting. Okay, we'll go in just a little bit further. Sounds like we have consistent cut down there. That looks good. Very nice. Just a little sanity check here. Just make sure we're 0.5. Again, not precise, but that's right on the money. So we've got 0.5, and we're going to go in and part this guy off. And there we go. Pretty darn good finish on this end. I won't have to face this off at all. I just got to deburr it. All right, next we got this piece of cold rolled here. And the outside diameter of it, this is the part that I just cut off of the drive assembly for the distributor. And this little flange here mates up against a part on the engine, and so he wants the outside of the shaft to be this exact diameter. First off, we're just going to face this guy. I'm lucky that the bore of this lathe is larger than the diameter of this cold rolled. I think I have 2 5/8 bore diameter. So fortunately that let me take this 12-inch bar and put half of it on the other side of the chuck. Just an okay finish. Cold roll just finishes miserably. Never liked it. I'm going to try this triangular insert to see how it works, reducing material thickness. And I think we're going to bump the feed rate up just a little bit here. That was 2.2 thousandths revolution. So for the first pass, we're going to head for 9 thousandths of revolution, just see how it works. See if we can get any kind of decent finish out of here. We're going to go in for 25 thousandths. See how that works. So the finish looks good there, but because the feed rate's so fast, I can feel it with my fingernail. But it does look good. Last pass, we're going to go really slowly. Just 11 thousandths depth of cut. And you can see from the surface finish how dull this cut is versus the last one. So deeper depths of cut give a better surface finish, it looks like. So we're shooting for 2.1865. And on that last pass, 2.1866. Sorry, 2.1866. So, and I measured at the front and it was the same. I just want to make sure there wasn't a taper. So I'm going to take some Scotch-Brite to the outside, chamfer this edge, and then we got to bore out the center. Just take the sharp edge off. First we're going to start with the center drill, and we're going for 1.369 inches here. To try and keep my accuracy up, I'm going to start with this stubby screw machine size drill bit first. What you really need for deep boring holes is coolant through bits and a tailstock that supports coolant through. Nice thing having some of your cutting fluid in one of these long needle stainless steel coolant things is you can reach into the hole and add some lube. Next up, 1 inch. Actually, there's a 31/32. There's some beefy chips right there. And in case we're wondering what the depth is like, about 4.5 inches, which is more than plenty. Next up, we're going to bore out the center. This is I think a 3/4 inch solid carbide boring bar, except for the end piece. So hopefully that'll give me some stability to go really deep. We got to go a little over 4 inches deep here, so that's kind of crazy. Let's just make sure everything clears. Yeah, that's good. And 4.25, we're hitting the bottom. I really need 3.8, so this is good. So the first pass, we're gonna do about 25 thousandths and just get a feel for where we gotta go. I've got the feed rate turned up a bit. I wonder if I'm going to get some chip packing because this is so deep. I don't have a lot of experience with deep bores. Maybe I should have parted this off and bored it with the other end free. That way the chips could push out the back. I'm not sure. Okay, that worked all right. Let's see how badly we got chip packing in there. Oh, the chips were breaking. Well, that's good. What I decided to do was do the clearance side first, which is 1.4 inches, and then I'm going to part this off, flip it around, rechuck it, and I'm going to do the inside, the last 6/10, the interference fit, because that way I can have less stick out and less chance of chatter. So that's what I decided to do. So we got our 1.4, and let's see if the part fits. Okay, just a little bit of slop. That's what you want to clearance, so this thing could mate in there and sit without rubbing. So it's got about 10 thousandths, 0.1 100 thousandths clearance inside there around the edge, which was intentional. So we're going to part this guy off, flip it around, and rechuck it up. There's another great place where these needle bottles work good well. And we're through. I flip the part around and I just make sure it's concentric, and this set true chuck is still within the 0.5 thousandth now that I flipped around, even though this is a slightly smaller diameter. So now we just need to bore this side out to our interference fit. And I don't know if you can see in there. Let's see, maybe I can add some light here. If you can see inside the bore there, this part's a little bit smaller diameter. We got to bring this down to the interference fit. 1 thousandth undersized. Sorry about the fan noise, but it's pretty hot here. So the next step is to take this piece that I originally cut off, which I wish I could have done this in one step, but the customer came back today to tell me what next steps he wanted. So I had to try and indicate off of this because that's the only thing that's concentric with the end. And the bore here is rough cast on the inside, so I can't indicate off that, and I can't even put it between live centers. So I've got this within a couple tenths, and this needs to be bored out to fit this split bushing here that's going to go inside. So I needed to get it pretty close, and then we're just going to bore it out. And actually the split bushing sits proud of the top of this. I don't know if you can see this. It's got a little notch in it, and the notch fits a bronze bushing, a washer that goes around it and locks in place with this. Let me see if I can find that for you. Here we go. So this is a pretty creative design. So you push this in till just this part here is proud, and then this guy fits on top of it and locks in place. It's a pretty close fit. And another surface rides on top of this on the inside. So we're going to bore out the inside of this, and that will be the next step. So we're going to start by taking a 10 thousandths cut, because I want to get my 0 here. We have to go in quite a ways, 1.140. Let's get our starting dimension here. I think I had about 40 thousandths to come off. 0.734, and it's going to 0.752. I think we'll take another 11 thousandths. Quick test fit. This isn't exactly a split bushing you thought it was. Oh, actually, maybe it does go all the way through, but there's not much gap here. So I made the fit really close, so this is already getting snug. So I think that should be perfect for him, and this piece should be done. If you wonder what it looked like, here's the whole piece. And remember, we parted off the top of this guy. I can go grab that for you. We parted off this part right here to give you some context. This sleeve used to go on the top, now it's going to go down here. The big piece that fits around the outside that we made, there's going to be a 1/4 inch plate that slides down that will duplicate this flange here that he's going to use to bolt this part down to the engine.